What is electricity? If we think deeply, electricity is a natural phenomenon which we can experience in day-to-day life. The main cause of electricity is charge. Charge is an inherent property of a particle, and this property creates electricity. So electricity and charge have cause and effect relation. Particles like electron, proton, neutron, which are matter, that means they have mass and they can acquire some space. These particles have mass, but at the same time they also carry some charge. Mass and charge goes hand in hand. After centuries of studies, we come to know that there are two types of charges: positive charge and negative charge. The name were suggested by Benjamin Franklin due to their different nature and this property to distinguish the two types of charges is called as polarity. We have studied two like charges repel, whereas two unlike charges attract each other because of electrostatic force of attraction. Then why an atom is called neutral, or why not two objects attract or repel each other? For this we will have to understand some basic properties of charge. The first property is quantization of charge. Let us take example of 1 rupees coin. 1 rupees coin is the minimum value of Indian currency. If we add 2 1 rupees coins, we will get 2 rupees. Similarly, if we have 3 coins of 1 rupees, we will have 3 rupees. But can we have 1.7 rupees or 2.1 rupees? Let us understand this with the help of number line. In this example, we can have 1 rupees minimum, 2 rupees, 3 rupees or 4 rupees, but we cannot have numbers in between. That means we can say that it is not continuous. Similarly, charge also has some minimum value. This minimum value is called as elementary charge, and its value is 1.6 into 10 to the power minus 19 coulomb. In electron, we have negative 1 elementary charge. In proton, we have positive 1 elementary charge. Suppose we have an object on which there are 7 positive charges, then the total charge or the net charge on that object will be Q is equal to plus 7e. If we have negative 7 charges, then we have net charge as Q is equal to minus 7e. So from these examples, we can say that the net charge on an object is equal to n times E, where n is an integer. If we try to make a statement, we can say that net charge on a body is always integral multiple of basic elementary charge. The next property of charge is additive nature of charges. Suppose on an object we have 5 positive charges and we represent it as q1 is equal to plus phi e, and if we have negative 3 charges and we transfer it to the object, the total charge on the object will be plus 2e. Here what we have done? We have done algebraic addition. Same way, we can say that an atom is neutral because the net charge is 0, and this happens because of equal amount of negative charges and positive charges in an atom. So, if we try to summarize this, we can say that net charge of a system is algebraic addition of individual charges inside that system. Third property talks about conservation of charges. Let us understand this with the help of a simple example. A central bank has the authority to print any amount of currency in that country. So, this currency is going to circulate from one person to another, and finally what we do? We again deposit that money to the bank. So, there is one complete cycle. Similarly, in a physical system or on a body, we have limited amount of charged particles. We can transfer some amount to another system or a body, but during this process, we are not creating or destroying any charge. So, we can say that charge can neither be created nor destroyed. They can only be transferred from one body to another. And for an isolated system, the total charge or the net charge is always constant.